from Marcus's Academy. In today's program, we have to treat a short way or a short algorithm we can actually employ when dividing a polynomial by a linear factor. Now, we call the method the synthetic method. Synthetic method. Okay. So this actually is a scheme or a way we can actually factorize a polynomial, okay, of a second degree, third degree, fourth degree, etc. Okay. And how do we do that factorization? Actually, we can divide. Suppose we have f of x, okay, to be the polynomial. We can actually say that g of x is the linear factor, okay? So let's explain synthetic division. We just say that this is a method. This is a method which we can use to divide a polynomial p of x, which we can use to divide a polynomial p of x by a linear factor f of x or g of x by a linear factor g of x. All right, so synthetic method, okay, actually is a method which one can use to divide a polynomial, okay, p of x by a linear factor g of x. So suppose a polynomial p of x is given to you, and you are given a linear factor g of x, okay, as your divisor. All right. Then how do you do that without the use of what? Long division method of what? Polynomial. So that borders on what? Synthetic division. So let's do this. Okay. Suppose you have p of x, that is a polynomial, p of x divided by g of x. Okay, so right equal to 2s cubed minus x minus s squared minus 7x plus 2. I say the question now, the p of x is 2s cubed minus s squared minus 7x plus 2 divided by the g of x, and where the g of x is simply a linear factor, x minus 2. Now, given this question, actually, our expectation is to factorize this, okay? Do a long division, okay, with the linear factor being our divisor. But we may take a whole lot of time if we want to use the long division method. So, in that case, to save our time, we employ the division, synthetic division. That is, we synthetic divide the p of x over what? G of x. So, doing this stuff, we have, first of all, the linear factor, which is x minus 2, okay, will be set. Let me come again. the linear factor now, x minus 2, normal, okay? It's what we're supposed to use. Suppose we are doing log division, but now in the case of what? Synthetic division, we shall not use the binomial as our factor. Rather, we shall use a whole number. And the number there, the constant there is what? 2, all right? So we will not use minus 2. Actually, we will just use the alternate sign of what? Minus 2, which is plus 2. Understood? So now we draw a line, okay, and instead of writing minus 2 here, we write plus 2. Suppose the linear factor is x plus 2, then we should have written what? Minus 2 here. But because the factor is what? X minus 2, then we take only the whole number in its alternate sign, that is plus 2. Okay? So, having written that, we draw another line on the bottom. Okay? Then in this case, we have to write out the coefficients of the p of x, that is the polynomial. Write out the coefficients of the polynomial according to the way they are being arranged. Suppose there is any term that is missing, you will substitute 0. But here the terms are what? Complete. The x with the third power, the x with the second power, x with the fourth power, then the constants. Okay? Suppose that any term misses, then we should have put it 0, okay? There. But there's no term that is missing, for all the terms are what? Complete. So let us write out their coefficients. You write 2, minus 1, yep, minus 7, yep, then 2. All right, so these numbers are the coefficients of what? The variables, okay? So we go again. All right, so we extend this line here. All right, okay. So now at this point, since you have written the coefficients of the variables, okay, given, now let us synthetic divide. We have put it into its normal form. We shall bring down these 2 here, okay. We shall bring it down, okay. So doing that, we have 2 coming down here. We have 2. All right. So now let us multiply. Multiply these 2 outside. Multiply these 2 outside the line, the vertical line. Multiply the 2 outside the vertical line, okay, by these 2 downward here. All right. When you do that, 2 times 2 will give me what? 4. So we come here. We come inside this bracket and write 4. Okay. All right. We shift. 2 times 2 is 4, so we write 4 here. All right. Then let us, from this second column now, let us what? Sum, okay, the numbers. Minus 1 plus 4 gives me what? 3. So I come down here and write what? 3. All right. Okay. Do you see how easy it is becoming? Again, we multiply 2 by this 3. That's 2. What we normally use to multiply is the number down, okay, for a particular column and the 2 outside the vertical line. So again, we proceed, or we repeat the same process. 2 times 3 gives me 6. Okay, so I write 6 under minus 7. I write 6. All right. So I write 6. Okay. Then I now sum or take the summation of what? Minus 7 and what? 6. Okay. So minus 7 plus 6 gives me what? Minus 1. All right. So I come under here, under the horizontal line, and write minus 1. Okay. All right. So I repeat the process again. I multiply the 2 outside the vertical line by the minus 1 under the horizontal line to have what? Minus 2. To have what? Minus 2. Okay, to have minus 2. All right. So, have you seen to have minus 2? All right. Okay. All right. So now, when I sum 2 and minus 2, I shall have what? 0. I shall have what? 0. Okay, underneath the horizontal line. All right, as it is now, let me repeat again, okay? I says the 2 outside the 2 outside the horizontal, the vertical straight line, okay, is the coefficient of the constant coefficient of the linear factor. Okay, if you watch, it was formerly x minus 2. Now we should have taken minus 2, but now we take plus 2. Okay, suppose it was to be s plus 2, we should have taken what? Minus 2. But in this case, it is s minus 2, so we take what? The plus 2 now. Now, we place it outside what? The vertical line. Then we came to write out the coefficients of what? The variables involved, okay? From the polynomial, that is the numerator, or our dividend. All right. Now, we bring down the 2. Now, we are doing the synthetic division right now. We bring down the first term, okay? That is the coefficient of the cubic what? 10. We bring it down to what? Underneath what? A horizontal line to still have 2. Then we multiply these 2 now underneath, and these 2, okay, at the left hand side, or the 2 outside the vertical line. So 2 times 2 gives me what? 4. We place the 4 under the minus 1, okay, inside this line now. So we now sum the minus 1 and 4 to have what? Plus 3 underneath the horizontal line. We do the same thing again. 2 times 3, we have 6 under what? Minus 7. We sum minus 7 and 1, 6 to have what? Minus 1. We do the same thing again. 2 times minus 1 gives me what? Minus 2. We sum 2 and then minus 2 to have what? 0. So, actually, at this point, we have seen that r of x is what? 0. R of x is 0. Okay? There is no remainder. Okay? R of x is what? 0. So now let us set this in its normal form or its standard form now. Okay? The term, okay, underneath the horizontal line will now form our new what? Polynomial expression. But in this case, it will be a quadratic what? Expression right now. Okay? So we have finally reduced the cubic expression to what? A quadratic what? Expression. So that gives me 2s squared. Okay? 2s squared. 2s squared plus 3 plus 3x minus 1 plus the r of x, okay? Which is what? 0 divided by what? X minus 2. Okay. So, have you seen the term under, that is the numbers, okay? The digits under this horizontal line right now, that is 2, 3, minus 1, and 0, okay? Now form the new what? Expression after we have synthetic divided, okay? The normal or the original polynomial expression by the linear factor x minus 2, okay? So now what we have right now is 2s squared plus 3x minus 1, because 0 divided by x minus 2 is what? 0. So it's vanished already. R of x is 0, meaning that what we have here is a factor theorem normal. But we have to treat factor theorem very well in our next tutorial or in subsequent tutorials, okay? There is no remainder. All right, we still have to treat our remainder theorem and long division, okay? So this will be our part 1. All right? So this is how we can synthetic divide a given p of x over by a linear factor g of x. All right? Without wasting our much time. Hope this helps. By Makasi Chinedu. Please, I am responsible for any typographical error found in this video. Subscribe to my YouTube channel, Makasi's Academy, where I teach mathematics, economics, econometrics, and quantitative economics. Thank you so much.